Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am your Madam Ruby. We are going to continue with our lesson 15. Lesson 15 is from chapter 3, Atomic Structure. In lesson 15, Quantum Mechanical Model, we are going to define the term orbital, and we are going to describe all the four quantum numbers n, l, m, and s, and we are going to learn how to sketch the shapes of s, p, and d orbitals with their correct orientations. Electrons are situated in a place around the nucleus where we call that place energy levels. Energy level can hold a certain number of electrons. The first level, which is the nearest to the nucleus, will hold only 2 electrons. This is the 2 electron. The 8 electron will be on the second level. This is the 8 electron for sodium, which has 11 electron. So the 1 electron here at the third level would be the electron valence for sodium. Some people think that this energy level is in circle, like the ones here for sodium. But it's not actually like this. It's not like the orbits of planets around the sun. For very complicated reasons, it is impossible to know how an electron is actually moving in an atom. So these circles just represent the energy levels. What is atomic orbital? Orbits are the definite path whereby a planet moves around the sun. But orbitals is the region of space inhabited by electrons. It is actually impossible to draw the orbits for electron because Heisenberg uncertainty principle said that you cannot know with certainty both where an electron is and where it's going to be next. That makes it impossible to plot an orbit for an electron around a nucleus. Again, orbital is a region or volume of space around the nucleus where there is a high probability of finding an electron. Orbitals have 4 characteristics, 4 quantum numbers, which is n, l, m, and s. As you can see in figure 3.9, the black dot there is the nucleus of an atom. And the shaded green area is where 90% of the electron density is found for the 1s orbital. If we plot electron density against distance from nucleus, we would find that the electron density for the 1s orbital falls off rapidly as distance from nucleus increases. Now let's talk about quantum numbers. What is quanta? Quanta are the discrete amounts of energy that an electron absorbs or releases. Electron absorbs energy as it moves up an energy level. An electron releases energy when it moves down to lower energy level. But what is energy levels? It is certain regions surrounding the nucleus. So quantum numbers will be defining the properties of an individual electrons in an atom. There are 4 types of quantum numbers. N is for principal quantum number. L is for azimuthal quantum number. It is also called angular momentum quantum number. M is for magnetic quantum number, and finally S is the spin quantum number. Now, let's look at the quantum numbers one by one. N is the energy level of where the electron is. It can have integral value of 1, 2, 3 until infinity. The larger the value of n, the greater the average distance of an electron in the orbital, and the larger the orbital is. So you can see here the principal quantum number n equals to 1 is small, very near to the nucleus. N equals to 2 is larger. N equals to 3 is even larger, away from the nucleus. So the higher the n, the increased energy and size of the orbital is. Azimuthal quantum number L indicates the shape of the orbital. The value of L depends on the value of n. For a given n, L has a possible integral value from 0 to n minus 1. For example, if we give you n equals to 2, L has a possible value from 0 to 1 because 2 minus 1 is 1. 0 represents S orbital. 1 represents p orbital. And 2 represents d orbital. We're going to learn the orbital of L quantum number up until D, SPD. F, G, and H is a different level. This is more explanation on the example that I have said earlier. For example, you have n equals to 2. Therefore, the L has the values of 0 and 1 because it's n minus 1. So 2 minus 1 is 1. So 0 means that it has s orbital, and 1, it has p orbital. Thus, the orbitals are 2s and 2p respectively at the n equals to 2. The 1s orbital has lower energy level and smaller size than the 2s and 2p orbitals. Let's do another example. We've done n equals to 2. Let's look at n equals to 4. When n equals to 4, the L is 0 until n minus 1. So in this case, n minus 1 is 3. So the orbital would be s orbital because it has 0, p orbital because it has 1, d orbital because it has 2, and f orbital because it has 3. So this determines the shape of the volume of space whereby the electron is occupying that space. The third quantum number is m, magnetic. It describes the orientation of the orbital in space. Permitted value for m depend on the value of L. For example, the L is 1. So it has integer value ranging from -1 to +1. The quantum number is -1, 0, and +1. The number of permitted value of n also indicates the maximum number of orbitals for a particular value of L. Just now, we look at L equals to 1. So the M is negative L until positive L. So if L equals to 1, M is negative 1, 0, or 1. Another example, if you have L equals to 2, which is the e orbital, the M is equals to negative 2, negative 1, 0, 1, or 2. Based on this basis, M indicates the orientation of the orbital in space. We will learn how to draw the orbitals after this. More explanation on the example. When L equals to 1, M is equals to negative 1, 0, and 1. Thus, there are 3 values of M. Or the number of p orbitals is 3, oriented along the x, y, and z axis. This is the y-axis, x-axis, and another one is z-axis because it is a 3D drawing. The fourth one is spin quantum number. It defines the direction of an electron's rotation on its own axis. Electron, it behaves as if it was spinning. Since the electron can only spin either one of the two directions, either it is clockwise or anti-clockwise, the spin quantum number has the value of positive half and negative half. So you can see here that the spin quantum number S would give you the value of positive half and negative half. That's an experiment when the electron is beamed onto between two magnets, and it was found that one electron goes up and one goes down on the detecting screen. We have come across several terms now: shell, subshell, and orbital. What are shells? Shell are the place where the electrons exist with the same value of n, whereas subshell is a place where electrons with the same values of n and l. Orbitals is even smaller because it has the electrons having the same values of n, l, and m. The question is, how many electrons can an orbital hold? If n, l, and m are fixed, then s is half or negative half. Ultimately, an orbital can hold 2 electrons. Next question. How many 2p orbitals are there in an atom? That's 2p. When we look at that number and abjad, 2 means n equals to 2. P means L equals to 1. Because you know that for n equals to 2, L is 0 and 1. 0 stands for S, 1 stands for P. So now we want to relate between L and M. So M equals to negative 1, 0, or positive 1. There are 3 numbers there, meaning that there are 3 orbitals. There you are. 2px, 2py, and 2pz. We are going to learn how to draw this later. Next question. How many electrons can be placed in the 3D subshell? Okay, you can see 3D, n equals to 3, and the D is standing for L equals to 2, because when you have n equals to 3, L equals to 0, 1, or 2, whereby 0 is S, 1 is P, and now 2 is D. If L equals to if L equals to 2, then M equals to -2, -1, 0, +1, or +2, meaning that you have 5 orbitals. And 5 orbitals can hold the total of 10 electrons. الآن أريد أن افتح في صفحة 91. Okay, اكتب quantum numbers في جدول 3.4. هل فهمتم هذا quantum numbers؟ اكتب quantum numbers في shell equals to 3, shell 4, n. Now, let's draw the orbitals. This is basically the steps. You have to draw and label the axes X, Y, and Z, and then draw the shapes using 3D drawing, and then we have to label and give name to the orbitals. Let's draw S orbitals now. Okay, now let's learn how to draw the S orbital. Firstly, I am going to draw a straight line indicating that this is the y-axis, and then another straight line indicating this is the x-axis, and this is the third axis, which is Z. It's 3D, remember? So the orbital S is only a simple spherical shape like this. Okay. And then we need to label the shape. What is the N? Is it 1? Is it 2? If it's 2, then we label this as 2s orbital. As you can see, 1s orbital is smaller than 2s orbital. And if you have n equals to 3, the s orbital would be even larger. Now let's draw p orbitals. There are 3 types of p orbitals. Okay, so before anything, we would like to draw the what is that? The axis. We have 3 sets of axes. This is the y, z, and x, y, z, and x, another one y, z, and x. So the first p orbital would be 2px. The second one is 2py. The third one is 2pz. So p orbital is in the form of dumbbell. So we find the x-axis and then we draw a dumbbell on the x-axis. This is not really beautiful. I'll try another one in y here. 2py. Y is a dumbbell on the y-axis, and 2pz is a dumbbell on the x-axis. There you are. The last part of drawing the orbitals is the d orbitals. It's a little bit complicated as there are 5 of them, and they are dxy, dyz, dxz, dx square minus y square, and the last one dz square. So how do we draw them? Let's proceed drawing for D. So firstly, I'm going to draw the axis, and D x, y is the first one. This is y, z, and x. So x and y is, this one is also x. So we want to draw a loop in between x and y, and another one against it. And z is not here, so we need to draw on z, one loop, and against it. So this is dxy. So let's do the second one, y, z, x. This is d, y, z. We need to draw between y and z. So this is straightforward. Draw a loop here and another one back here. And there's no x on the name, so we have to draw on x, the second dumbbell, if you want to say it's a dumbbell. And then we have to draw the third one, y, z, x, d, x, z. So where is between z and x? This one, right? So you draw one loop and another one at the back, and you draw another loop on y. So this is dxz. Okay. The fourth one is you have to draw, this is y, z, and x. This is dx square minus y square. So you have to draw on x. This is quite straightforward, on x and on y. Okay. And lastly, okay, this is a bit different. Okay. I want to draw z over here, y over here, and x over here. You can exchange the axes actually. So we need to draw the loop on the z because it is d z square, no, z square, and you have to draw a loop. This is called a loop, a special feature of dz2, dz square. So that's how you draw the d orbitals. Here is a bit of a peek on the orbitals of F. Look how beautiful it is. And the orbitals of G. Wow! Excellent creation from Allah subhanahu wa ta'ala. Alhamdulillah, we have finished lesson 15. Thank you very much for watching and see you again soon. Bye!